So let's talk about how you write an equation given that you know what the graph is, but you're trying to come up with the algebraic equation that represents it. Well, there's a couple ways to do it. The easy way is when you have a graph that looks like this. I say it's easy because, if you remember, we were given a couple of different formulas, or hopefully you've been given a couple different formulas, and one of them is this, y equals mx plus b. And if you know the slope of an equation and you know the graph or the y-intercept, you can just plug into that and be done. So as I look at this graph up here, I notice that the y-intercept is up here at 1, 2, 3, 4. So I know my y-intercept's at 4. And then I also know that I can figure out my slope fairly easily. I can simply go from this point to this point. So I'd go up 2. So I go up 2, and then I go to the left 2. So that'd be negative 1. So I get y equals negative 1x plus 4, or just y equals negative x plus 4. And there you go. There's the equation of that graph. Now, unfortunately, they're not always that easy. For instance, let's take a look at this one. Now, you notice the difference between this one and the previous one is that we don't know exactly what the y-intercept is. You know, we can maybe guess that it looks like it's about 2.5, but we don't really know if that's 2.5, 2 2/3, so we don't know that. But we do have 2 points. I notice that I have this point over here at negative 2, 1, and then I have this point at 2, 1, 2, 3, 4, at 2, 4. So how do I write the equation given these? Well, remember we have this thing called point-slope formula. And so I already know a point. I actually know 2 points. I just need to figure out the slope. Now you can do that 2 ways. One is you can use slope formula to figure this out. Do y2 minus y1 over x2 minus x1. Or I could just count. And I'm going to choose to count because that's a little faster. So I'd go up 1, 2, 3. And then I go to the right 1, 2, 3, 4. So my slope is 3/4. So I'm going to use this information. I'm going to use this point over here. And I'm going to plug in. So y minus 4 equals 3/4 times x minus 2. Simplify. Y minus 4 distribute equals 3/4 x minus. Now 3/4 of 2 is going to be 6/4, which if you then just reduce that, it would be 3/2. I'm going to add 4. Y equals 3/4 x. So here, if I'm going to add these, 4 is the same thing as 8/2. Okay, so if I have negative 3/2 plus 8/2, that's going to be a positive 5/2. Okay, and there you go. There's your equation. Y equals 3/4 x plus 5/2, or 2.5, which that would be a pretty good guess if we would have said 2.5. Okay, last one. Now, this is 2 graphs in one. Let's talk about this one right here first. Okay, these are kind of special cases, so you put a little asterisk right here to remind you that these are special cases. So if we talk about this one, this is a vertical line. Remember, all vertical lines have undefined slope. Remember, we also talked about how every vertical line is going to follow this equation, x equal something. Well, what is the x-coordinate of every point on this graph, or on this line right here? Well, the x-coordinate of every single point is negative 2. So there you go. X equals negative 2. Now let's talk about the other one. This is a horizontal line. Remember, on a horizontal line, my slope is 0. And this is another one that's kind of a special case. This is going to be y equals something. Well, what's the y-coordinate of every single point on this line? Well, the y-coordinate is negative 2. So this one's going to say y equals negative 2. So there's the equation of that one. And then here's the equation of this one. And there you go. There's about every different scenario that you're going to come across to write the equation given a graph.